Stoichiometry is a method that we use to calculate quantities of reactants and products in chemical reactions. For example, in the reaction between hydrogen and oxygen, which produces water, if we wanted to produce 300 grams of water, what mass of hydrogen gas would we need to have in order to produce 300 grams of water? So if we're going to use stoichiometry, there are 5 basic steps. Step 1, we need to start with a balanced equation. Step 2 is what I call housekeeping. What I mean by that is determine how much of your givens you have and what your unknown is, and place them in the appropriate places on the equation. So according to my problem, it says what mass of hydrogen gas, so that means I'm going to put X grams over hydrogen gas, would need to react with unlimited oxygen gas to produce 300 grams of water. So I want to produce 300.0 grams of the water. My housekeeping's done. Now I know what it is I'm solving for, and I know what my reactant is going to be. So step 3 is convert to moles. So I'm going to take my given, my 300 grams of water, and to convert grams to moles, I'm going to make an X, draw a line. We want to bring the units, grams of water, down into the denominator, and I want to convert to moles, so I'm going to put 1 mole of H2O in the numerator, and 1 mole of water, according to the masses on the periodic table, is 18.02 grams. Step 4 is our molar ratio, and the mole ratio between our water, our given, and our hydrogen, which is what we're solving for, is going to be a 2-to-2 ratio. The mole ratio comes from the balanced equation. So then, I'm going to bring moles of water down, and I'm going to put moles of my unknown, hydrogen, in the numerator. And from the balanced equation, I see that it's a 2-to-2 ratio. Now we're ready for step 5, which is convert to solve. And since I'm trying to solve for grams of hydrogen, what I will do then is make another X and another line. We'll take moles of hydrogen from the numerator and bring it down into the denominator. So moles of H2 here, and we want to end up with grams of hydrogen. And so 1 mole of hydrogen is 2.02 grams. And then the last thing that we need to do would be to multiply everything that is in the numerator and divide by everything that is in the denominator. And we see that we would need 33.63 grams of hydrogen in order to produce 300 grams of water. Suppose we have a solution that contains 3.50 grams of sodium phosphate, and it's mixed with a solution that contains 6.40 grams of barium nitrate. How many grams of barium phosphate could we produce? Well, we know we're trying to figure out grams of barium phosphate, but we're given 2 amounts of reactants. And so which one are we going to use to determine how much barium phosphate will be produced? Well, whichever one is going to be consumed first is going to be the one that determines how much product we're going to make, or going to be able to make. And so the substance that gets completely consumed in a chemical reaction is called the limiting reactant. Now, there are a few different ways that you can approach a problem like this. The first thing that you can do is to start with one reactant, starting with our 3.50 grams of sodium phosphate and following the steps to stoichiometry. We're going to use the molar mass of the sodium phosphate, which is 163.97 grams, is 1 mole of sodium phosphate. Then we do our mole-to-mole ratio, and there are 2 moles of sodium phosphate for every 1 mole of the barium phosphate. And then our final step would be to take our moles of barium phosphate and to convert that to grams. And the molar mass of barium phosphate is 602 grams. Multiplying across the top and dividing by the bottom, 6.42 grams of the barium phosphate. Then we would do the same thing with the barium nitrate, the 6.40 grams of the barium nitrate. And we'll follow the steps of stoichiometry again, converting grams to moles, and 1 mole of barium nitrate is 261.33 grams. And after we convert to moles, we do our mole-to-mole ratio. So we're going to take our moles of barium nitrate, are given to our moles of our unknown, which is our barium phosphate. And in the balanced equation, barium nitrate is a coefficient of 3, and barium phosphate again is a coefficient of 1. And then our final step is going to be to convert moles of barium phosphate, 1 mole, to grams. And our molar mass, we said, was 602 grams for the barium phosphate. And when we used our other reactant then, and we multiplied across the top and divided by the bottom, in that case we get 4.92 grams of barium phosphate. Since this is the lesser amount, that means that the barium nitrate was our limiting reactant, and this is the actual yield from that reactant. So that's the long way of doing it. There is a shortcut. There are a couple shortcuts that you can use. The easiest one is the one that I'm going to show you next. Take both of your given amounts and convert them to moles. So we'll start with our 3.50 grams of sodium phosphate, which is 163.97 grams per mole. That would give us 0.0213 moles of the sodium phosphate. We'll do the same thing with our other reactant, our 6.40 grams of barium nitrate, which has a molar mass of 261.33 grams per mole. So for moles of the barium nitrate, then, we get 0.0245 moles. Then what we want to do is we want to divide each of those by their respective coefficients from the balanced equation. And for the sodium phosphate in the balanced equation, we had a 2. So we'll divide by 2. And that gives us 0.0104 as our magic number. And for the barium nitrate, the coefficient in our balanced equation is a 3. So if we divide the moles by 3, we get a magic number of 0.008. Whichever number is the smallest, in this case, this one, is going to tell you that that's your limiting reactant. Once you've determined what the limiting reactant is, get rid of this. This number is meaningless. Okay? And so what you would do then is use your grams of barium nitrate to complete the stoichiometry problem. So we would take our 6.40 grams, convert that to moles, do our mole-to-mole ratio, which is 3 moles of the barium nitrate to 1 mole of the barium phosphate, and then convert to grams. 1 mole of the barium phosphate, we said, was 602 grams. And we get the same answer, which is 4.92 grams. So I hope this helped you to understand how to calculate a limiting reactant in a stoichiometry problem.